Have you ever wondered how companies like Google, Netflix, and Square handle millions of requests between their services without slowing down? Or maybe you've built REST APIs and heard developers constantly talking about something called gRPC. What exactly is it? Why are so many modern systems moving toward it? And should you be using it in your next project? In this video, we're going to break down gRPC, from absolute beginner concepts all the way to production-ready architecture decisions. By the end, you'll know when to use gRPC, when not to use it, and why it's becoming the backbone of cloud-native applications. Let's jump in. Before we talk about gRPC, let's understand the problem it solves. In modern applications, services constantly communicate with each other. Your authentication service talks to your user service, your payment service talks to your order service, your notification service talks to everything. The question is, what's the fastest and most reliable way for these services to communicate? That's where gRPC comes in. Think of it as a high-performance communication framework designed specifically for service-to-service communication. Instead of manually building HTTP endpoints and parsing responses, gRPC makes remote communication feel almost like calling a local function. Pretty cool, right? Let's imagine a simple scenario. Suppose there's a function running on a server in San Francisco. Now you're sitting in Tokyo and want to execute that function. Normally, you'd need to send HTTP requests, define routes, parse JSON, handle errors, and so on. With gRPC, you simply call the function as if it exists in your local application. The framework handles all the networking complexity behind the scenes. That's why RPC stands for Remote Procedure Call. You're calling a procedure on a remote machine. In simple terms, gRPC allows developers to focus on business logic instead of connection logic, and that's one of the biggest reasons developers love it. Now, here's where things get interesting. Traditional REST APIs usually exchange data using JSON. JSON is human-readable, but it's also verbose. A lot of extra characters get transmitted over the network. gRPC uses something called protocol buffers, often called Protobuf. Instead of text, data is converted into a compact binary format. Think of it like compressing your data before sending it. This gives three major benefits. 1, smaller payloads. Less data travels over the network. 2, faster serialization. Encoding and decoding are extremely efficient. 3, strong typing. Your data structures are clearly defined beforehand. And here's the best part. You define your service once in a .proto file. Then gRPC automatically generates client and server code in multiple programming languages. No repetitive boilerplate, no manual API client creation, just generate and start building. One of the biggest advantages of gRPC is streaming. REST is mostly request response, but gRPC gives you 4 communication patterns. Unary RPC. This is the simplest one. Client sends 1 request, server sends 1 response. Think of it as a modern REST call. Server streaming. The client sends a request once. The server continuously sends updates. Imagine a stock market ticker or live sports scores. 1 request, many responses. Client streaming. Now flip the direction. The client continuously sends data. The server responds only when the upload is complete. A great example is uploading a large file. Bidirectional streaming. This is where things get really powerful. Both client and server can send messages independently at the same time. Perfect for real-time chat applications, multiplayer games, collaborative editing tools, live trading systems. This capability alone makes gRPC incredibly attractive for modern real-time systems. Now that we understand the basics, let's talk about why engineering teams are so excited about gRPC. The answer is simple. Performance. When your application grows from thousands of requests to millions, communication efficiency becomes critical. Every millisecond matters. Every byte matters. And that's exactly where gRPC shines. In many benchmarks, gRPC can be anywhere from 5x to 10x faster than traditional REST communication for internal service calls. Why? Several reasons. Binary serialization with Protobuf, HTTP2 multiplexing, persistent connections, reduced network overhead. Imagine hundreds of microservices talking to each other every second. Even small performance improvements multiply dramatically at scale. That's why many organizations adopt gRPC internally, while still exposing REST APIs externally. Best of both worlds. Traditionally, gRPC runs on HTTP2, and HTTP2 itself is already very powerful. But the future is HTTP3. HTTP3 is built on QUIC instead of TCP. Why does that matter? Because it solves some long-standing networking challenges. Zero head-of-line blocking. With TCP, one lost packet can slow everything down. QUIC avoids that issue. Connection migration. Imagine moving from Wi-Fi to mobile data. Your connection stays alive, no interruption. Zero RTT reconnection. Reconnect almost instantly. For mobile applications and edge computing, this is a huge advantage. This is why many engineers see gRPC over HTTP3 as the next evolution of high-performance networking. Now, let's be realistic. Every technology has trade-offs. Let's look at both sides. Why use gRPC? Extremely fast, efficient bandwidth usage, strong typing, automatic code generation, excellent support for microservices, multi-language compatibility. Why skip gRPC? Binary data isn't human-readable. Debugging can be harder. Browsers don't natively support it. Often requires gRPC web or proxies. Protobuf introduces extra setup complexity. So if you're building a simple CRUD application, REST might still be the better choice. The right tool depends on the problem. If you're wondering whether gRPC is production-proven, the answer is absolutely yes. Some of the world's largest engineering organizations rely on it. Google uses it extensively across internal systems. Netflix leverages high-performance service communication at massive scale. Square adopted gRPC to support scalable financial infrastructure. When systems handle millions or billions of requests daily, communication efficiency becomes a business advantage. That's where gRPC delivers. So when should you choose gRPC? Here's a simple rule. Internal microservices? Choose gRPC. You get performance, type safety, and generated code. Public APIs? Choose REST. Everyone can consume it easily. Mobile backends? gRPC is often a great choice because it minimizes bandwidth usage. Web frontends? REST or GraphQL usually provide a smoother developer experience, especially because browsers natively support them. Remember, REST is for accessibility. gRPC is for efficiency. The smartest architectures often use both. So let's recap. Today, we learned what gRPC is, how remote procedure calls work, why protocol buffers make it fast, the 4 streaming models, why gRPC outperforms REST internally, how HTTP3 and QUIC are shaping the future, and most importantly, when to use it and when not to. If you're building microservices, distributed systems, AI platforms, or cloud-native applications, gRPC is definitely a technology worth learning. If you enjoyed this video, don't forget to like, subscribe, and share it with fellow developers. And let me know in the comments, are you using REST, GraphQL, or gRPC in your current projects? I'd love to hear your experiences. Thanks for watching, and I'll see you in the next video.